All right, so we're going to take a look at common differences and how to calculate them and what it means when they are the same. So first of all, we're going to talk about first differences. This is a set of differences between consecutive terms in a sequence. So if you're given a sequence of numbers and you keep subtracting one term from the next, that will give you the first differences. And what's interesting is if those first differences are the same, then the function is considered linear. And it's the function represented by that sequence of numbers. All right, second differences, as you can imagine from the name, is the set of differences between the consecutive first differences. So when you calculate out the first differences, you're getting a new sequence of numbers. If those are different from each other, they're not all the same, you're going to then calculate the second differences using that new sequence. And if those happen to be the same, the second differences, then that means that the function will be quadratic. So if you created your function based off of the original sequence of numbers, it would give you a quadratic function. All right, so let's do an example. Here are the numbers in my sequence, and I'm calling them output for right now because you'll see what we do with this next time. Okay, so to generate your first differences, you're going to take 2 and subtract 6. So that gives you -4. And then you're going to do 0 minus 2, which gives you -2. 0 minus 0 is 0. 2 minus 0 is 2. 6 minus 2 is 4. And then 12 minus 6 is 6. So you notice that the first differences all came out to be something different. So we're going to go ahead and do this again to generate the second differences. So be careful with your minus signs. -2 minus a -4 gives you a +2. 0 minus a -2 gives you a +2. 2 minus 0 is 2, 4 minus 2 is 2, and 6 minus 4 is 2. And so because the second differences are all the same, we know that this original sequence here represents a quadratic function. Now, had these been different, and we continued on to figure out the third differences, and they were the same, I bet you can extrapolate from that and think that it would generate a cubic function, and you would be right. Because we have this general theorem here that says with finite differences, if an equation is a polynomial of degree k if and only if the kth row of differences generated by the sequence is constant. So what this means is whatever row of differences you get, if they're constant, then that's the degree of the polynomials. So because the second differences here were all the same, it's a quadratic or degree 2. If the third differences were the same, it would be cubic, degree of 3. If the fourth differences were the same, then the degree would be 4. So just a little fun fact there. All right, so that should be fairly easy to work with just to get some practice in before we start building our functions based off of our sequences. Have fun!